So to get going, we're going to be talking about the continuum from ecosystem degradation to ecosystem restoration, and what we as foresters and natural resource managers and other people interested in general ecosystem health in urban areas can do to make our to restore our ecosystems after starting with degradation. And of course, the definition of degradation and restoration, is very subjective. Everyone probably looks at those words and has different thoughts. But Rich is going to talk later about restoration in terms of the urban work that he's working on, and I will, and you'll get a good feel for restoration in the context of cleaning cleaning degraded sites as I speak. And so we're really looking at this continuum, like I said, and oftentimes what we find is that people get the impression that they can go from degradation to restoration by walking along this bridge, this road, and it's going to be very easy, and they're going to get there, and they're going to put some trees in the ground, and everything's going to work. But what we've realized, and what has been known for quite a long time, is given the anthropogenic impacts that we as humans have caused, it's not that easy. It's not just a matter of putting some plants in the ground without knowledge of those plants, without knowledge of the contaminants and potential pollutants that are in the groundwater and soil, and things like climate, so precipitation and soil conditions and all of those kinds of things. And so today we'd like to take you on a little journey, and we'll continue the journey, and we'll start the journey by discussing a brief restoration ecology primer, and then continue that on, and I will discuss work that I've been doing with regard to phytoremediation. So this, for those of you who don't know what this is, don't worry about it. Don't feel daunted right now. You'll learn a lot about it in a few slides. And then I'll pass the baton over to Rich, and he'll discuss some afforestation work. So the greening portion of the presentation, as you saw before. And lastly, especially for those of you, it looked like from that poll that the majority of you were from city and county governments, and also other people that have these types of sites, interested in developing partnerships with the U.S. Forest Service and with our other colleagues to try and move from degradation to restoration. So Rich will lead that as well. And so ultimately what we'd like to do is get you to the point where we provide you with some information that you can put in a toolbox to say, okay, now we have some options to move from degradation to restoration. First, we'll just go through some terms. You'll hear us talk today about ecosystem services. The most basic definition is the benefits people obtain from ecosystems. You can see on the upper right there the cover page of the Millennium Ecosystem Assessment. And so this is another one of those terms where, if you have 100 people in the room, you're probably going to get 100 different definitions. We're trying to put them into the context of what the MEA says, and the Millennium Ecosystem Assessment breaks it into 4 categories. Cultural services, which are these non-material benefits obtained from ecosystems, so the spiritual, educational values, in addition to supporting services. So, take yourself back to high school biology class when you went through the nitrogen cycle and the water cycle and all of those processes that maintain ecosystems. In addition to provisioning services, so what we get from the ecosystems in terms of goods or products. So this could be, biomass for paper or structural lumber in addition to fresh water. And then lastly, regulating services. So things like erosion control, soil quality, and these are really, these are the benefits that we get from the control of those processes that were up there in the supporting services. So I said I'd talk about restoration ecology, and for some of you, you've probably seen this many times, but one of the keys to phytoremediation, and what I talked about on that introduction slide, is the concept of moving from ecosystem degradation to restoration. Oftentimes, what we find is that when we initially speak with, say, a landfill manager or the manager of an industrial brownfield or someone from a regulatory agency, there's a misconception that you can go straight from degradation to restoration. If we put this continuum on this scale, we see species diversity and complexity on the x-axis and positive ecosystem function on the y. That can be anything, plant biomass. It could be, diameter of the plant. It could be the amount of berries you get off of a plant, something like that. But the point here is that there are all of these RE words, recovery, rehabilitation, reclamation, that have to occur before you get to restoration. And one of the most important there from the standpoint of what we're speaking about today is remediation. And so with remediation, it's the step before we get to restoration. And the important thing here is about plant selection and thinking about what plants, number one, can be grown on these polluted sites. Number two, what plants can actually take up and clean up the soil that is at the contaminated sites and ultimately move us to restoration. And so I define these as the workhorses. And so we know that there are 3 or 4 genera of trees that are workhorses, and I'll get to those in a minute. And I want to depict what I'm really kind of what's in my mind anyway. When I saw this picture, I like this from the standpoint of here's a good healthy tree that's growing where nothing else will grow. So obviously the trees were cut down, but there was and you can see a lot of bare soil and bare sand there and everything. But what we're really looking for are these trees that really will grow when virtually nothing else will grow there. From a phytoremediation perspective, you'll hear me talk about this word. I just mentioned it, and like I said, for some of you, this might be the first time you've ever been exposed to this concept. Essentially, it means using trees to clean up contaminated sites. So that could be soil, it could be groundwater, it could be sludge along a riverbank where there's petroleum hydrocarbon contamination in a canal, for example. And I'm not going to get into the details of this because it's not the point of the presentation today, but what I do want to highlight here is that there are many processes with phytoremediation, and they all relate to 2 things. The first is where in the tree the actual breakdown or uptake of the contaminants occurs. So you can see a lot of processes going on here in the root system. For example, rhizofiltration, where there's actually active transport of pollutants that are going through the roots up into the stem and leaves of the tree. You also have something like rhizodegradation down here, which actually is not actively taking part in the plant roots, but it's taking part in the soil. And the plant roots are creating an environment for microorganisms to live, and those microorganisms are actually breaking down and eating the contaminants. And I won't describe these processes in detail now. If anyone's interested, we can certainly have a conversation after the call, or I can give you some literature about it. But just want you to think of the concept of breaking down the pollutants in various tissues of the tree, and also, like I said, with those microorganisms in the soil environment. The second thing related to phytoremediation that's really important is related to the kinds of pollutants that are at these sites. And so from a chemistry perspective, there are organic contaminants and there are inorganic contaminants. Organic contaminants contain carbon. These are typically, human-made things like petroleum hydrocarbons or TCE, PCE, so these industrial solvents, and there are just a whole slew of them, most of which most of us probably can't even pronounce. The inorganics are things like heavy metals, salts, other, something that you would see in the periodic table of the elements. So moving on, so in addition, phytoremediation with these workhorse trees is important because of 3 traits of interest. The first is elevated water usage. And you'll see in some of the slides that I have coming up, this is really important from the standpoint of hydraulic control. So gaining control of the groundwater and being able to suck that groundwater up through the tree and take it out of the soil, while simultaneously the tree is cleaning the pollutants out of that water. In addition, fast growth and extensive root systems. So examples of these workhorse species, I mentioned before, the genera that we typically use. Two of them in particular, poplars and willows. So this is the genus Populus and the genus Salix. And they are what are called phreatophytes, so they have the three traits that were on the previous slide. So the rationale really for phytoremediation in general and cleaning contaminated sites. Imagine this is a leaf, right? And it's from a tree that's growing in a really heavily polluted, heavily contaminated site, and it's just hanging on, and it's about to die and fall off. But what we're really looking for are those workhorse trees that can act like the Incredible Hulk and can say, you know what, we're going to go in there and we're going to clean that up, and we're going to find a way to be healthy in the process, and we're going to create a more sustainable, healthy ecosystem while doing it. And so that's the whole, in my opinion, the overarching rationale of phytoremediation. This slide shows examples of some projects that we've done in recent years. I'm not going to go through every one, but you can. The take-home message of this slide is to just show the diversity of the kinds of sites, systems, and issues that we deal with. So you can see a lot of landfill stuff on the top, but then also these industrial brownfields. And then, like I talked about before, inorganics and organic contaminants. And then the system. So what is it really used for? Some of them are actually used for remediation per se. Other things you can see there, a riparian buffer. So in addition to actually taking up the contaminants, just establishing establishing the trees on the shoreline to reduce erosion and other impacts is just as important. So I'll go through some examples from north central Illinois, northeast North Carolina, Panama City, Florida, and then also Rhinelander, Wisconsin. This is the LaSalle, Illinois site, which is on that previous slide. Sorry. You can see the trees there at 11 years old. So this is a site that is, heavily contaminated with TCE and PCE. So these are industrial solvents that are used in primarily things like the manufacture of batteries, and they survive in the soil a long time, and they're really difficult to get rid of. The trees at the LaSalle site in the photos that you're seeing are at 11 years, and I won't go into great detail, but if someone is interested, I definitely would like to have the conversation. You see there 19 clones. So imagine you had a family that had 19 siblings. That's essentially what we're dealing with here, or 19 varieties. Like if you're going to go into the grocery store and get different kinds of apples. And so the names on the top of those pictures, the Crandon, the 7300, 501, and the 220-5, are clonal names. So these are different trees that we've identified to be good for cleaning up these types of contaminants. And you can see the diameter at breast height underneath there. So at 11 years old, Crandon, exhibited 8 inches of diameter. 220-5 exhibited over 12 inches. And what does this mean from a practical standpoint? It's at this site, these trees were growing almost 20% greater than what we would expect in the region if we were to grow trees on non-contaminated sites. So this is an example of a very good, very successful phytoremediation system. Now I'll go in contrast to that. This is a study that collaborators are conducting from North Carolina State University at a U.S. Coast Guard base with soils contaminated with petroleum hydrocarbons. And I'm talking about 2 different plantings. They're both 5 years old, and you can see here, it didn't show up on the left axis, sorry. You can see this is for tree diameter, so diameter at breast height. And what I want to point out here is kind of going back to this concept of needing to test and select certain workhorse species and certain workhorse clones. And if we look at the 2 bars on the left, where the blue star is, those belong to the same family. They have the exact same genetic parentage. The ones on the right have their exact same genetic parentage. And you can see here at this particular planting, the clones are segregating by family. However, at this third one, you can see it totally breaks down. And the point here, and the take-home message here that I want to show to you is the importance of plant selection. And you can see if we would have just gone by the results at what's indicated there as Elizabeth City 2, we would have thought that the family on the right was superior. But then you go, not that far away to Elizabeth City 3, and it becomes an issue of having to select a specific variety. And so I think I'll leave it there, but like I say, the point is trying to match specific varieties, specific clones to the contaminants. And I'll drive that home a little later here as well. Oh yeah, one thing I'd also like to point out is, so we saw a plus 19% increase in versus the expected diameter in the region. For these plantings, you can see minus 40%, minus 46%. So an example of something where the trees were alive, they're healthy, but the growth is stunted. But still, in my opinion, a success from the standpoint of having something grown on those polluted soils. The last example that I'll show you some data for is from Panama City, Florida. This is led by a collaborator at the University of Florida. It's an industrial brownfield with arsenic contamination in the soils. And the trees were almost 5.5 years old when the data were collected. And you can see here on the bottom, these bars represent 15 different clones. And what I want to point out is just the variability. So if we look at the worst clone to the best clone, and the x-axis isn't showing up again, but the top one is for diameter, you can see 102% increase when you go from the best to the worst. Likewise, this bottom graph is for biomass. So the dry, woody, above-ground biomass, and you can see a 340% increase. So once again, just that take-home message that that selection of specific trees is really good. Here, expected diameter again, 8.9. So you can see it's in there. It's kind of in the middle of the other two examples that I showed you. And then for biomass, 7.2. So it's a little lower, but still, considering the contamination in the soil, not bad. So this slide really is the crux of what phytoremediation means to me personally, and what our program is working on is this identification of specific clones with the tissue, integrating the specific clones with the specific contaminant and what tissue those contaminants are going to go into. So I'll give you an example. If a brownfields manager calls and says, we have cadmium and chromium in our soils, what would you suggest? The ultimate goal would be to be able to say, okay, should we use poplars or should we use willows? That's the first question. Once we've answered that question, and it's cadmium, where do we want it to go? We probably want it to go into the woody tissue. Therefore, let's use clones X, Y, and Z. So that's kind of the practical nature of what we're doing here. And obviously, we don't have this matrix for every single pollutant that's available out there, but we're moving in that direction, and that's one of the things that that our research is really focused on. So I'll give you some picture examples. This is an industrial production facility in the Midwest. Soils are heavily contaminated with salts, metals, and nitrates. These trees are 11 years old. You can see very healthy. You see I don't really have anything in the picture in terms of seeing the diameter growth, but very, very nice stand of trees. In addition, this is a landfill in northern Wisconsin where leachate was used as irrigation and fertilization of the trees. This is at 8 years. You can see very dense. These trees were planted pretty tight, so you can't see anything through there, and they haven't begun to self-prune yet. But once again, you can see general overall health of the trees there. In addition, another situation where we had a landfill manager at our county landfill here up in up in northern Wisconsin that was extremely progressive and proactive and really valued the benefit of research and trying out new things from the standpoint of sustainability. And you can see here, well, I say fiber cake recycling. So we have a paper mill in town, and he worked it out so that the paper mill would deliver their fiber cake to the landfill, and there were asphalt pads that you can't see on the left side of the photo there, and they would dump the fiber cake on those asphalt pads, and with precipitation and infiltration through the fiber cake, it would then run into a collection pond, and then he used that leachate to irrigate and fertilize the trees during establishment. And so you can see here at 12 and a half years, I wish someone was standing in there, but you can see the posts. Those posts are 10-foot posts, so quite huge trees, really. And so with all of this, and one thing that I really want to stress is that tree planting is strategic. And it's strategic from the standpoint of biology and ecology and getting the benefits, carbon sequestration and other benefits for the environment. But it's also strategic from the standpoint of communities. So in this situation, I used the example of redevelopment. We want to create green space, increase livability, decrease direct contact issues with these pollutants, and then in some situations actually get some economic value of the trees. So we really want to think about what we're putting out there based on what the pollutants are in the soils, and really move forward with something that we think can get us from degradation to restoration in a stepwise approach rather than trying to do it all in one step and then having the system fail. And so this is just another pictorial. Typically, in rural areas and stuff, and the concept of it is, moving from these degraded lands to healthy ecosystems. Now that we're working more along the urban to rural gradient, and especially for those of you today that work in urban environments all the time, we're taking that same concept and bringing it to the city and bringing it to urban communities. And so if you're interested in this, I have a research review that our Northern Research Station did a couple winters ago that really that drives home kind of the points that I've talked about today.